Okay, so we're going to go over the quiz from Wednesday, April 15th. The first question states that the function f is given by f of theta equals negative cotangent of theta. Which of the following is the graph of y equals f of theta in the coordinate plane? So negative cotangent of theta is equal to two things. It's either equal to 1 over tangent theta, negative 1 over tangent theta, or it's going to be equal to negative cosine of theta over sine of theta. And so what we're really going to look at is this one over here, because if we're looking at the graph, we're trying to find the inverse. So if we're looking at cosine of theta over sine of theta, we're trying to look to figure out which one of these graphs, A, B, C, or D, is our inverse, which is our cotangent, negative cotangent of theta. What we really need to look at is where are asymptotes occurring. Our asymptotes occur whenever our denominator is equal to 0. So in this case, when is sine of theta equal to 0? When does this occur? So sine of theta is going to be equal to 0. We think about our unit circle, or we think about the graph of sine. So what I'm going to show you is the graph of sine. So the graph of sine is going to be, on our calculator, looks like this. We notice that our asymptotes will occur from our inverse function whenever our sine is equal to 0. Our sine is going to be equal to 0 at x is 0. If we go to the right, at our x is equal to pi, at our x is going to be equal to 2 pi. If we go to the left, our x is going to be equal to negative pi, our x is going to be equal to negative 2 pi, and so forth. So what we're really looking at is for our graph where our asymptotes are occurring at, we said 0, pi, 2 pi. So if we look at each of our graphs and we want to draw our asymptotes, we can draw our asymptotes like this. And I'm going to draw our asymptotes on each of our graphs. So at 0, at pi, at 2 pi, at negative pi, at negative 2 pi. So notice already the first two that I've drawn, one of them is already eliminated, and one of them is not eliminated quite yet. And then when we're looking at the other graphs, so let's look already at choice C. We're eliminated because we have points hitting our asymptotes. Choice C is eliminated. Same thing with choice D. We have points hitting our asymptotes, so it can't work. We're left with A or B because we have our asymptotes lining up. So to figure out whether it's going to be A or B, we're going to look at our negative sign. So remember, the graph of a tangent function will always go from highest to lowest, or it's decreasing. Notice how our tangent functions, right, are always going to be decreasing. However, when we're taking the negative version, cotangent, it's going to be choice B because we're increasing. It's the opposite. And another thing is you guys were able to use a calculator on the quiz, so you could have put in this function in the quiz in your calculator. So to do that, even though we technically do not have a cotangent function, what we do have is we know that the inverse of cotangent is 1 over tangent. So when we put it into our calculator and we graph it, it looks the same as choice B. So the answer to question 1 is choice B. Going on to question 2. So the function f is given by f of x is equal to sine of x plus 4 pi over 3. So already what we know how to do is when we're doing our trig identities, we know that we have a sine and we have a plus sign. So it's going to be sine of x plus sine of alpha times cosine of beta plus cosine of alpha times sine of our beta. So in this case, it's going to be sine of our alpha, which is x, times cosine of our beta, which is 4 pi over 3, plus cosine of x times sine of our beta, which is 4 pi over 3. This is still f of x. This one is still f of x. Now what changed is instead of f of x, we're doing f of 3 pi over 4. So f of 3 pi over 4, what we're going to do now is change our x's to 3 pi over 4. Anytime we see an x, we're going to substitute it with 3 pi over 4. So this is what we're left with. And then now all we have to do is simplify. So sine of 3 pi over 4 is actually the negative square root. Sorry, it is not negative. It is square root of 2 over 2. Cosine of 4 pi over 3 is negative, negative 1 over 2. Plus cosine of 3 pi over 4 is negative square root of 2 over 2. Sine of 4 pi over 3 is equal to negative square root of 3 over 2. Now we're going to simplify a little bit more. To simplify these fractions, square root of 2 times negative 1 is negative square root of 2, all over 2 times 2, which is 4. Plus negative square root of 2 times negative square root of 3 becomes positive square root of 2 times 3, which is 6, all over 2 times 2, which is 4. The final combination we get is negative square root of 2 plus square root of 6, all over 4. So this is not one of the options here. However, to make it one of the options, we're just going to switch the order of the numerator. We're going to switch negative 6 minus square root of 2 over 4. And this is where I think a lot of you guys got mixed up, because I saw a lot of people pick choice B. So you had the numbers, however, you switched the negative signs. So if you chose choice B, I gave you half credit. But the answer for question 2 is choice D. Now, the last question that you guys had was to use trig identities to write secant theta over cosine theta in terms of a single trig identity. So we have secant of theta over cosine of theta. Secant is actually going to be equal to 1 over cosine. And then it's over cosine theta. So remember, keep, change, flip. We are going to keep the numerator, change the division symbol to multiplication, flip the order of the denominator. So instead of cosine over 1, it's going to be 1 over cosine theta. When we simplify this, 1 times 1 is just 1. Cosine theta times cosine theta is cosine squared theta. Some of you guys stopped here, but there is one more step. The last step is to do our trig identities. 1 over cosine is secant. So 1 over cosine squared is going to be secant squared theta. This is our answer to question number 3. I posted the grades on Jupyter, so if you guys want to see your grades, go look on Jupyter. If you have any questions, send me a Jupyter message or come talk to me before school, after school, during class, whatever.